In this lesson, we're going to continue to look at displacement reactions. In particular, we're going to look at the displacement of a metal from a solution of its salt by another metal. So just before we start, we can say that a more reactive metal will displace a less reactive metal from a solution of its salt. So in these two test tubes, we've got two solutions of salts. In this case, we've got a solution of magnesium sulfate. That's also known as Epsom salts. So what that means is that the magnesium sulfate powder has been added to water and have been dissolved in the water. So we've formed what is called an aqueous solution. And in the other test tube, we've got this characteristic dark bluish colour of a solution of copper sulfate. Now, to each of these solutions, I'm going to add a sample of zinc. Okay, in the magnesium sulfate and in the copper sulfate solution. As soon as we do that in the copper sulfate solution, we'll notice that the zinc immediately starts to change colour. And very quickly you'll notice that a darkish brown coloured substance is deposited on the surface of the zinc. Now that substance is copper. Now what's happened is that because zinc is higher than copper in the reactivity series, that's to say it's more reactive, it displaces the copper from the solution and forces it to be deposited on the surface of the zinc in its element form. So let's write out the equation for that. We start off with zinc and we add it to copper sulfate. Okay, let's put aqueous, that means in solution. Then the zinc displaces the copper ions from the solution and copper then becomes deposited on its surface. So we get copper and then the zinc goes into the solution to form a solution of zinc sulfate. Now zinc sulfate is transparent in colour, so after a while you'll notice that the solution of copper sulfate becomes transparent as it's changed into zinc sulfate and copper. Now this happens only because zinc is higher up than copper in the reactivity series. When we add the zinc to magnesium sulfate, well, zinc is now below magnesium in the reactivity series, and so it's unable to displace magnesium from its solution. So this reaction doesn't go, hence the no entry sign. And that's because zinc is lower down in the reactivity series than magnesium. Now I would like to tidy this up by writing the symbol equation for the reaction of zinc with copper sulfate. That always helps us to understand what's going on. Okay, so we can write out the symbol equation. We have zinc plus CuSO4. That gave us copper plus zinc sulfate. Now then, let's just have a look at these aqueous solutions. What they are really are solutions of ions, as I mentioned earlier. So really what we've got here is zinc plus, and then in solution we have copper 2+ ions. They're still in solution, so we'll put AQ plus the sulfate ion. That's a 2-. Okay. Now then, what happens then effectively is because zinc is more reactive, it forces its outer electrons onto the copper ion and forces the copper to change into its element form. Okay, so one way of saying that is that the zinc reduces the copper. So we write Cu here, and then the zinc has now lost its electrons to the copper, forced the copper out of solution, and as a result zinc ions form which are in solution. So we now get a solution of zinc 2+ ions plus the sulfate ions. They remain there. Now it's these copper ions which give this dark blue colour to the copper sulfate, and the zinc ions are now colourless. They just result in a clear, colourless, transparent solution.